Hello and welcome to another PolyWorks webinar. Today I'm going to show you how simple it is to create an inspection program with the help of the Microsoft Hololens and PolyWorks AR to do a full inspection, and also in collaboration with FARO today we'll be using the FARO laser tracker. Here's FARO UK to explain the hardware in more detail.
Hi, I'm Paul Lewis, an account manager at FARO Technologies UK, and I'm here to give you an introduction to the different range of trackers that FARO Technologies have. We have two 3DOF laser trackers, the E and the S, as well as the 6DOF laser trackers, the E6 and the S6. The E and the E6 have a measurement range radially of 35 metres, while our S and S6 go up to 80 metres radially. We have infinite rotation around the horizontal axes and the vertical axes. All of our laser trackers have the same spec, so we have around 10 metres away from the tracker, you can get an accuracy of around 99 microns. All our laser trackers are IP52 rated. That means waterproof, dustproof, so it basically means they can be used in any extreme conditions. We have ActiveSeek technology. ActiveSeek means you can go away from the laser tracker and the laser beam will follow you. You can go around obstacles, jigs and fixtures, and the laser beam will jump from one side to the next without you having to keep the beam locked onto the centre of the SMR. This makes, for the basic operator, things a lot simpler to use laser trackers. And as it's a market leader 50 degrees field of view, you can go around larger obstacles. We have complete Wi-Fi technology with our dual antennas on the side. This means that we get a solid connection to our laptop. So even with cranes and other interference, we should get a solid connection constantly during a measurement routine. We can also have batteries connected to the back of the laser tracker, so we can have complete wireless technology, so we can go into the middle of a shop floor where there's no power socket readily available, and we can use the laser tracker for up to 12 hours with two batteries. With our 6DOF laser trackers, we have the option to use our 6 probe. Now our 6 probe is a kinematic probes at the end. We have a 6 mil diameter by a 50 millimeter length probe in at the moment. Once calibrated, it is a known distance from the center reflector down to the center of this red ball here. With the chip technology, it recognises which length probe you have in. So if I switch between a 6x50 and I change to a longer probe, so a 250 by 6, I can pop that in, connect, and pick the beam back up into the centre reflector, and it will automatically recognise now that we have this probe in. The idea behind the 6 probe and the reason why this can be a useful piece of kit is it can get where the SMR can't get. So if you've got a surface at the back of a part or an internal bore that the standard SMR can't get into, we can turn the probe on its side and we can get into the back or around the side where the SMR can't get to because of line of sight issues. Our 6 probe has hot swappable batteries at the back. So they are standard Canon batteries that clip into the back of the 6 probe. When this battery starts to become a bit low, you will see the colour of the LED here change to an orange or a red if really low. We can then take it out, switch to a new battery, and then we'll get another 5-6 hours of measurement time with that battery. The 6 probe works between 2.5 to 15 metres away from the laser tracker and has an accuracy of 95 microns with the 6x50 probe, and again that accuracy will go up the further away you go away from the tracker or the longer the probe length that you use. So basically that's a quick introduction to our range of laser trackers and the 6 probe. If you have any questions or you want more information on our trackers, then please don't hesitate to contact your local account manager, who will be happy to provide a demonstration and more information on our trackers. Thank you for joining me.
Okay, so let's dive straight into PolyWorks, where I've already imported the CAD model of the inside of the car door, and we'll start to create some geometry, come up with an alignment technique, do an offline simulation, and then we'll create a very quick report, ready for us to then transfer that over to the HoloLens, ready to run the inspection with guidance through PolyWorks AR. So we already have the CAD model imported in, and we'll start by creating our kind of master circle, master slot, followed by a couple of reference target points to help finalize the alignment technique. So we'll jump into our features. Let's call this a specific name, call this the master circle. And I'll pick on CAD, and let's pick on this hole here. Next up, we'll create a master slot. And we'll use this slot here. And with those two features, we can create our feature reference target points from objects. We'll leave the alignment directions as they are for the time being because we'll tweak them afterwards. So let's create that for the time being. And we have our feature target point 1 and 2. So get the alignment directions correct, we'll have to jump into each of them one at a time. So for our first target, which is our master circle, we only want to align that in two different directions, which is the Z direction and the X direction. So we don't need Y. We'll jump into our next feature, which is our master slot. And this only needs to be constrained in the Z direction. It can slide slightly in X, and obviously Y will be controlled by the surface target points that we'll add in the next stage. So let's untick those. And we've got Z left ticked on its own. The surface reference target points can be created either by just manually picking, which I'm going to do here, but obviously typically on your drawings you'll have your, hopefully the numerical values for these target points. So I'll start with a point here, let's go down here, and we'll finish off on the far right here. So 3 points normally enough, and obviously we're technically doing a 3-2-1 alignment here. So with those created, set up, we do probably want to tell PolyWorks how we're going to measure these. So let's tell PolyWorks how we're going to measure our master circle first. So I'll right click, go to properties, jump into the measurement tab, and obviously we're going to probe these. Now, what we're probably going to do initially is measure with the standard kind of 1.5 inch reflectors, which will probably be too big for this hole here. So what I'll do is use a sub-method of hole smaller than probe. What that simply allows me to do is probe a couple of points to create a constraining plane, and then all I need to do is rest the reflector within the hole as much as I can, take a single point, it knows the size of the reflector, it knows the size of the hole based upon the intersection of that plane. So we'll have one fixed point, we'll probe 4 points for the constraining plane. We can even go as far as telling PolyWorks exactly what size reflector we're using. So we'll specify reflector, and at the moment we have nothing specified in there, and that's purely because it doesn't know what tracker we're using yet. So all I need to do is tell PolyWorks I'm going to use the FARO laser tracker, and now you'll see I get a list of reflectors available to us. So I'll choose the 1.5 inch, and the probing mode can be left as undefined, or you can specify single point at a time, continuous time, continuous distance, which will continuously take points based upon time or distance. Here, just single will do, or leave undefined, it's up to you. And if you want, we can even add a guiding instruction, which will actually appear within the PolyWorks HoloLens guiding instructions on the visuals. So here we'll say probe 4 points for the plane, 1 point for the hole. Apply that. Currently, the HoloLens can't display additional images for guidance, just purely text at the moment. But there could be future developments on that side. So apply, we'll jump into our next feature, which is our slot. And again, what we'll do is we'll tell PolyWorks that the slot is too small for the probe. So we'll use hole smaller than probe again. And again, we'll fix the number of points for the constraining plane. We'll tell it which reflector we're using. and we'll be taking single points at a time. And again, I'll just mention probe 4 points for the plane, 1 point per arc. Apply and close. We have a couple of other features that we may want to probe, so we'll probe these additional three features here. So we'll set up some new features. They can be named automatically this time, and we'll go circle, circle, slot, and we'll even create just an extra circle down here as well. And again, it's worth probably telling PolyWorks exactly how we're going to probe them, and I will be switching up slightly. One of the benefits of using the Vantage is FARO have the 6 probe. So rather than just using the reflector, we have a portable probing device with a smaller probe, which will allow us to get into some of these smaller holes. So what we'll do is we'll tell PolyWorks how we're going to probe our 2 circles. Again, properties, change the method to probe. Because we'll have a small enough probe to get inside the holes, we'll leave the sub method on standard. We're going to probe using a local plane. These are internal holes. And we can fix the number of points. So we'll say just 3 points for the plane, 3 points for the circle, but ultimately for yourselves, it'll be down to you to determine how many points you want to be taking. I could, if I wanted to, specify the actual probe, but again, all that can be detected automatically anyway, so it's not critical. And if I like, I can add in an extra instruction just to kind of remind myself that I'll be switching over to the 6 probe. So switch to using the 6 probe. Okay, we'll do the same for our slot 1. Again, we'll have a local constraint plane. These are internal holes, and we'll fix the number of points to say 3 points for the plane, 3 points per arc. Apply. Again, feel free to add in your guiding instructions if you wish, but we won't need it here. And then we have our circle here. In this situation, well, in this example, sorry, I'm going to switch back to a reflector, and I'll show you some handy little tools to do with that process as we go through. So let me just jump into the properties here. Tell PolyWorks that we're going to probe this again. Again, we'll have to use the hole smaller than probe. Probe local plane, 1 point for the hole, 3 points for the plane. And I will remind PolyWorks, which will remind me that I'm using the reflector for a single point. And if you need to, type in an actual extra guide message just to kind of reinforce that, to remind you again to switch back to 1.5 inch reflector. Okay, apply that. So we've got some features set up. We'll have the alignment ready to go. And let's just finish this off by adding a couple of comparison points dotted around that we can measure using, again, guidance from the PolyWorks AR. So we'll add some surface comparison points, and I'll just dot a couple across the surface of the part, and we should get guidance for each of those. Again, if you like, feel free to right click on those, go to properties, just to remind PolyWorks that we'll be probing these. Okay, and all those can be left as they are. Again, feel free to add any guiding instructions if necessary. And that's pretty much the inspection program created. The only thing missing is the alignment, which we can't do until we measure something. But what we can do is do that offline and get PolyWorks to pretend to measure it so we can generate the alignment technique. And then we can, once we have all the data, we can then finish off by creating the report for it. So to do that, I'm not currently connected to the hardware, but I can turn on my offline simulation mode, and then I can actually connect to a virtual tracker. And with that connected, we're going to run through a reference target alignment. But what we're going to do in this example is we're going to run specifically the reference target alignment by probing. And what this allows us to do is probe, and while we're probing each of the reference targets, it will start to snap the part into place. And so the beauty of this is once we probe our first 2 features, it should get us somewhere near, giving us a little bit closer guidance to the 3 remaining surface points. So we'll jump in there. It's got those reference targets already set up. So if I simply hit probe, it will run through and measure those for me. And we now have our alignment set up. Once we've done those measurements, we'll probably then jump back to finishing off measuring the features. So we'll highlight those features, right click and say probe measured. Hit probe, and again, it'll run through that automatically for us, pretend to probe those features. Okay, close, and then we have our surface comparison point. So again, highlight those, right click and say probe measured, and it should simply run through and measure all those for us. Now that's complete, we don't need to be connected to our device anymore, and also worth remembering to turn off the offline simulation mode. Otherwise, if you run through a new piece, it will just re-simulate the entire data again, making up the data. So we have everything set up now. We can finish this off by creating a report. So let's start off by generating a report to do with our reference target alignment. So spread these out. Take a snapshot, add it to our report. So this is our door inspection, reported by me. If I jump into a report page now, you can see we have our report set up. We have our first snapshot. Let's add in a table of the results for the actual alignment. Let's also capture the CAD model on its own for reference. Don't actually need any of those annotations, so let's turn those off. So we have just the CAD on its own. Capture that. Go back into our 3D scene. Let's report just our features now. So again, I'm going to spread out these annotations. And this time around, what I'll do is create the control view from objects within the 3D scene. So here you'll see it will take a snapshot and create a table based upon what results we have visual on screen. So click on that and we're looking at our features. You can see there it creates a snapshot and a table for us. If I jump into my report pages, you can see there we have our snapshot, we have our table. We'll do the same again, but for our comparison points. So let's spread these out. And again, create a control view based upon what's visible, in this case, comparison points. Create, and again, you can see there, snapshot table. So that's the inspection program created. Let's just quickly save this. And then what we're ready to do is set up and connect everything to our devices. So we'll move over to the inspection table where we'll hook up the FARO laser tracker via Ethernet to the laptop, and I'll be connected to our internal network so we can then connect to the Microsoft Hololens. So now the project has been created, saved, the project saved, the workspace saved. That's it. There's nothing else you need to do on the PolyWorks side, especially with PolyWorks 2022. With regards to the HoloLens side, again, with the latest version of PolyWorks, PolyWorks AR 22, you no longer have to manually install anything on there. Previously, you had to kind of drag and drop files across using the Windows portal and install it that way. Whereas now, if you jump onto the technical support zone, jump into the software download section, you can see there is an actual PolyWorks AR 22 for HoloLens. Jump in there. It will give you the guidance in terms of if you do want to manually install the HoloLens, the PolyWorks AR for HoloLens. Alternatively, you can see there's a QR code that you can scan with the HoloLens itself. That will actually jump you to the Microsoft Store on the HoloLens itself, where you can then choose to install the application there. Once that's installed, you will get a little icon on your dashboard, which you can then launch the AR program with. So if I go ahead now and put on the headset, power on. So if you've never used the Microsoft Hololens before, a lot of the controls are gesture-based. So the idea of if I look at my palm of my hand, you can see in the, right where your pulse is, you've got the Windows logo icon, and you can see there we can then jump into our applications. So I'm going to launch the PolyWorks AR from here. And because this is on the same, this is connected to the Wi-Fi network, which is the same as what my laptop is currently connected to at the moment, it can see the actual project itself pop up straight away. If you don't see it, then you might want to actually specify your IP address by typing in the IP address there, but since it's already there, it's ready to go. Again, if you've never used the HoloLens before, you can see as I move my hand around based upon where my finger's pointing, you can see that there's like a, what they call a God ray that points up to a little marker. And if you want to click and accept the item, normally you just simply pinch your fingers together and you'll accept that option. If you walk up to the actual panel, you can actually just use your finger to kind of like pretend to press it if you wish as well. Currently, PolyWorks is now sending the information, generating the hologram information to be sent over to the HoloLens. So this can take a little while to process. Now it's downloading the project. You can see once this reaches 100%, it'll then give us the hologram of the door. Tells you it's successfully downloaded and gives you some guidance there. You can flick through to give you the options. Otherwise, hit OK. And you can see there we have a hologram on the right hand side. So here you can see my fingers are pointing. We have those God rays again, which allows me to simply pinch, pick the part up, and actually move it over to where the real part is. You can twist your hands around, tilt, pull it towards you or away from you. And then when you're happy with that position, you simply just open your fingers apart, like you're releasing the pinch, and you can see it just simply drops the part there. There are further tools that allow you to kind of fine tune this process. So within this toolbar here, I can click on the localization tools, and there's kind of two groups. There's the manual group and there's the automatic group. The auto locate is an automatic tool which will try and automatically align the hologram to the real part, but you do need a lot of space. I need to be able to back right up to see the entire part, and it will then try and align the best it can. Sadly, due to space limitations here, I'm unable to use that here. I'll go through the QR code options a little bit later on, but here on the left-hand side, we have an option to pin and also fine tune. So if I show you just quickly the add pins option, it tells you in the display to air tap to add pins. So again, with my fingers and the God rays, I can simply hover the marker over a point that I want to locate a pin on, and then pinch my fingers twice to create a pin. Once that's there, you'll notice that if I pick a pinch on a different area of the part and then start moving, it's now pivoting around that one part that I've pinned to, allowing me to kind of fine tune the alignment, assuming that where I position the pin is in a good location. If I want, I could also double pinch again to set another pin. That generates a line, which means now if I pinch somewhere else and start moving, you'll notice that it will start to pivot around those 2 points, like an axis. Okay. Alternatively, let's cancel that, and I'll show you the other fine-tune option, the actual fine-tune option, which gives me this kind of 3D coordinate system here. This can be moved. All I need to do is unlock the gizmo, pinch on that, and I can move it a little bit closer if I needed to. Again, twist if I needed to, and then let go. And if I'm happy with that position, I then lock the gizmo, and you can see now when I move, it doesn't move anymore. So from here, I will then start to fine tune the positioning either by pulling on the single axes or by rotating it using the curved arches. So if I want to move the part a little bit closer towards me, I simply hover over the blue line, pinch, and you can see that I can simply drag it forwards or backwards. Maybe I need to rotate it slightly along the green axis. So again, move your fingers until it highlights it, pinch, oops, wrong one, and then start twisting or moving left and right to rotate it. Same with the x-axis. Okay, and then feel free to move around to see if it's in the right position. And if you're happy with that, we can then simply say done. And you can say you get a proper preview now of the part. Now, if that time it takes to fine tune all that can sometimes be a little more time consuming, but once you've done it, if I bring up my palm again, you can see it brings up the PolyWorks home buttons. I can relocate again if I'm not happy with it, start moving around, but also I could also go into localize tools, QR manager, and I can save this position as using a QR code. So I've printed one out, just simply walk up to it into the scans, and you can see there, QR code found. So now that is remembered. So next time I launch this project, it will actually notify me that there is a QR code associated with the alignment. Do I wish to scan it? And if I do go ahead and scan it, it should automatically jump the hologram into the right position again. So from this position here, bring up my palm again. So just to show you, I have the options to look at my projects, or whether it's refreshing the project itself, jumping into a different project, or even saving the project if I've made any changes. I've shown you the relocate. There's a shortcut tool, which also takes me to the fine tune option. Can't view anything at the moment because we haven't measured anything yet. But if I jump into my measure tool, you can see we have our new piece and play inspect. So if I measure a new piece, warns me that that's going to save the project. Okay. So within the program itself, it will then start a new piece, which essentially wipes all the data from the offline simulation. It has to re-download the hologram again. It'll ask us about the alignment, but since nothing's changed or moved, we can bypass that. Again, once it reaches 100%, the model is transferred across, successfully downloaded. You can see there, it asks you, do you want to relocate the model? So we've already done the alignment, and since nothing's changed, I can say no. You can see the hologram reappears in the same position. So now that we have a blank project with our nominal, I can go to measure, and I can say play inspect. Straight away, you can see there's a guidance arrow pointing me towards the first hole, and a little window here that tells me exactly what I'm doing. I'm probing the master circle. I currently have 0 out of 4 points for the constraining plane, and there is the guiding instructions along the bottom there, telling me to probe 4 points for the plane, 1 point for the hole. You'll also notice along the bottom, we have some extra tools. Now, this will vary depending on whether you're using an ARM-based system or a tracker-based system. With a tracker, as you'll probably already know, when you're using a reflector, there's no way to simply trigger the measurement tool unless you tell it to using a remote. But as you can see here, we have the option to actually start the measurement or end the measurement here manually, as well as undo the point. I also have some additional tools, which you can see here allows me to reprobe the entire measurement, send the tracker home, so it points down at its chest where the nest is. But what's cool is now that we are aligned to the physical part, technically PolyWorks and the tracker will know where the headset is in space. So what I could actually do is tell the tracker to come to me, and the tracker would normally point towards me, but that's not the case here. I think we need to measure something first, and then it can jump to me. So if I send it home, I could also tell it to find targets. I can change reflectors. As you can see there, we have a list of different reflectors and a list that we can go up and down, go back. We have our probing options. So you can tell PolyWorks whether you're doing a single measurement or whether you're measuring using continuous time, continuous distance. Nothing else in there. So probe mode, you can see there, if you do choose to use continuous time, you can specify the time. If you're using continuous distance, specify the distance and so forth. There's also the automatic stability trigger, which rather than having to press the button to say measure, you can just simply hold it still enough, long enough, and it'll automatically take the point for you. And visibility, you can actually turn on a digital readout to give you your coordinates of where the probe is. You can turn this guiding arrow on and off if you want to, and you can turn the visual feature object off as well if you want. Now, as I move around, you'll notice that this window follows me around, but sometimes that can be a bit annoying. You can see here, it's currently in my way. So on the top right-hand corner, I can click on the follow me button. Now that I've unticked it, that will now stay in place. That won't get in my way unless I move into a position where it is. So if I pinch the top corner, I can actually move this a little bit further away from me closer to the part. Now that's not going to be in the way wherever I move. Okay, so let's go back, ready to probe this hole. So let's grab the reflector. Again, the arrows are pointing towards where I need to go. Simply move the probe into position. And I can say start, takes a point. If I'm still enough. Compensate. Okay, and then it changes to say 1 point in the hole. Okay, I've got the automatic stability trigger turned on, so it will also try and take a point automatically by holding still. Okay, so you can see there 1 point per arc. Okay, and now it's asking me to probe the surface points. So if I move back a bit, you can see there guidance points me to my first point. So again, just hold it in position. We don't need to worry too much about the position yet, because obviously we're not perfectly aligned yet. Sorry, let me just bring this closer to me. So I can manually say probe, bring it with me, further down to our next target point. Okay, now that's quite surprising because I've managed to probe those surface points pretty close to the point where it's happy with it. If not, it would actually ask me to say that the points are out of tolerance and ask me if I wish to probe them again. At which point I would have actually got a pop-up on screen telling me to go back to my computer to accept, to say yes or no to reprobing those. But it's moved straight on in this case. So you can also see that it's telling me to the constraining plane for circle 1, and I've added a guiding message saying switch to using the 6 probe. So I'm going to switch over to the 6 probe. Okay, so that's locked on. So I don't actually need the start-stop buttons on there anymore because the 6 probe has the buttons on there. So all I need to do is find out where the hole is, start probing. So compensate, and then probe my 3 points on the inside. So that's moved on. Now, I just want to pause this for one moment. So this obviously allows me to probe the holes however I like. However, what I could actually do is, if you've seen any of our previous webinars, we could take this a little step further. You can see the pop-up now because we're in the middle of doing something. So if I jump into my measurement tab, you can see we have our fixed number of points. But rather than just simply fixing the number of points, what we'll also do is add guided points. And this will force us to probe the points in a certain position, certain location. So if I zoom into the hole here, you can see we probably don't want to go as deep as that. go 3 mil there, but only 0.5 mil deep. Apply. And let's do the same for our slot, just to show you. Guided, again, only 0.5 mil deep. With, let's say, 3 mil offset from the end for the constraining plane, so apply. So now if I resume that, so as you can see, now not only is it showing me the actual hole that I need to measure, but it shows the actual measurement points themselves as well. So you can see there is besides being able to see the probe, I can see the virtual probe that's floating in space relative to the alignment that I have within PolyWorks. So obviously, due to the manual tweaking of the hologram, this may not line up perfectly, but the orange dot is actually correct. And I can use that to help me lock into place. Take a point. Compensate. And then it'll do the same for the inner holes as well. Okay, so we'll probe the hole like we did before. So you can see there, with the added benefit, as obviously you already get an audio tone to give you an idea of how close or how far. But the problem with the audio tone is it just tells you how near or far in all directions. It doesn't actually tell you which direction you need to be moving in. Now we've got extra guidance here to give us an idea visually of where to be moving to get closer to the target. Again, with the guiding instructions, it says to switch back to the 1.8-inch reflector. Lock back into place. And we're about to probe a hole further down. So again, let's bring this with us. We're probing this circle down here. And then 1 point for the hole. This is moved on to our comparison points. So let's bring this up. Come on, there we go. Again, if I step back slightly, I can see there we have our first comparison point. Again, audio tone to give you an idea of how close. Points me to the second point. So you can actually see now we actually have a big orange target floating around, and obviously it's mimicking the 1.5 inch rather than the 6 mil. Okay, and that's the inspection done. So now if I step back, You see we have our annotations showing us the actual values, at which point if I can't see them because they're overlapping, again, use your God rays to simply pinch, move the annotations either side or either way, spread them out, and you can see our results there. And obviously all this is updated in the project, which also means that the inspection report is all updated. So if I jump into our report pages, you can see there we have our results with our passes and fails. At which point I can either from this point here, bring in the menu, I can then choose to save the project. And if need be, I'm ready to measure the next one. Simply replace the door with obviously the next part. And again, bring up the menu and simply measure, new piece, play inspect. And we have our guidance. Currently, we are limited to only probing features and surface comparison points. Kinematic is still looking further into guidance with regards to other measurement tools such as cross-sections, gauges, and even scan data. But at the moment, that's as far as the guidance tools go. If we did choose to scan this, we can still have the color map displayed like you've seen in earlier versions of PolyWorks AR. But obviously we haven't got the scanner here to scan with. But yeah, that's just showing you the power of the guidance tool and the power of the HoloLens with PolyWorks AR. So hopefully that shows you how quick and easy it is to set up a program and deploy it through the Microsoft HoloLens using PolyWorks AR. Just a reminder, PolyWorks AR is available to anyone with the Inspector Premium license. And just a quick disclaimer as well, the footage that you saw through the HoloLens itself, it may look slightly off compared to what you actually see through your eyes through the HoloLens. Due to the kind of distance between the camera and your eyes and due to the recording processes, it may look slightly off and it may seem a bit drifty when recorded, but obviously that's different to when you actually see it through your eyes. But either way, any questions, any queries, or if you want to schedule in any demos, please feel free to get in touch with us through our support email address, telephone number, and please do follow us via our social media handles. Thank you for watching.